Now we'll cover outfalls and storage units. So let's start with outfalls. Let's go ahead and click right click and open attribute table and then dock the table. Then we need to go to back here to our shapefile descriptions, and let's go ahead and click on outfalls. And we see that outfalls is a point layer that contains the outfalls. Its attributes are name, invert elevation, flap gate, allow discharge, outfall type. I think that's actually a string, so sorry about that. This is a string. And this is water depth. Oh no, sorry, this is not depth. This is stage. Ooh, I need to fix this whole table. Okay, stage, tide curve, and time series. All right, and then your attribute table is here, so let's go ahead and open our attribute table. All right, and here we go. Outfall. Name. I like to put the O in front of the outfall. That way if I'm looking at output files or results or things like that, I can quickly find the nodes and I know whether I'm looking at an inlet or an outfall. Let's open this up a little bit. So now we have the name, and of course they have to be unique. We have the invert elevation, and we have whether or not they have a flap gate. Looks like I gave one of these a flap gate, that cistern, because it does not allow flow to return to the system. So that is why I turned a flap gate on for that system. The allow queue is yes is 1, meaning that it will interface with the Flow 2D system and discharge into, like, from the storm drain system into the Flow 2D system. So let's go ahead and zoom in on one of these. So if you're interfacing with a channel on an outfall, you need to interface with the left bank looking downstream. So let's grab this guy and click our channel element. So this outfall interfaces with this cross section. So even though it clearly comes in on the right hand side of the channel looking downstream, we still define it at the left hand side of the channel, because the left hand side of the channel is the side of the channel that interfaces with the channel cross section. So we always define our storm drain and and culvert connections on the left bank looking downstream. So let's see what else is, and then we got 1397.16, so that's probably slightly higher. As you can see, this kind of ramps down off of into the channel, so that's probably slightly higher than the bottom of the channel. That's okay. Flap gate false means that it does not have a flap gate, so water can move both directions. It can move from the channel up the storm drain system, or if the pressure in the storm drain system is higher, it will move down the storm drain system and out of the out into the channel. The allow queue is 1, so that means it will interface and share water back to the Flow 2D surface. The outfall type is free, and the different types are free, normal, fixed, tide curve, and time series. So if you had a fixed stage, it would go, this would be set to fixed, and this would be set to an elevation above, well, just any elevation above the invert elevation of the outfall. And then if you had a tidal curve, this would be, I think this is time and elevation, time in hours and elevation in feet or meters. And this is time series data, so this is time in hours and minutes, and I believe discharge in CFS, or cubic feet per second, or cubic meters per second. And we won't set these up until we get into the next series of videos where we talk about how to set up this data. All right, so that's an outfall interfacing to a channel. Let's take a look at one of these outfalls that does not interface with the grid system and see why. So let's zoom to one of these. So now this, and these are all fake, by the way. So these are all outfalls that I moved off the system just simply to show that if you had an outfall that, you know, inadvertently landed off your grid system because it was at the edge of your grid system and the storm drain kept going past your grid system, then you can do that with an outfall. That's okay. But it will be defined as, it will have no defined value. So when you export it, and it will not interface with the grid, and so your allow queue switch has to be set to 0. Okay, and again, the type is free. You could also assign any additional type to it to control the flow out of it, but it's just going to act like a sink. It's not going to exchange water with flow 2D unless there's a tide or something. Okay, then of course the exchange would be happening up here, you know, if there was a tide or something like that. All right, kind of hard to describe tide conditions in the middle of Arizona, so okay, that's outfalls, invert elevation, flap gate, allow discharge. This will be 0, 1, or 2, and type, fixed stage, tidal curve, time series. Now let's go here and find our outfalls, storm drain outfalls. So instructions on how to set up your storm drain outfalls are in here, and different outfall configurations, instructions about elevations and datums, things like that are all in here with respect to outfalls. All right, let's minimize this and go to the storage units, open attribute table, and let's go ahead and dock the table. Nope, wrong one. Okay, that's better. Okay, so storage units, in this case, storage units, let's look at the EPA Swim GUI for a minute, and let's look at storage units. So in like a standard swim model that wasn't a Flow 2D swim model, your inlets and nodes would be connected to storage areas. But we don't use storage areas in Flow 2D. Instead, we connect to the grid system. So for storage units, they have all kinds of variables that represent surface water issues. So for example, ponded area, infiltration, evaporation, things like that are all related to detention basins and retention basins and stuff. So we don't do that with Flow 2D. So our storage units that you can represent in Flow 2D are closed storage units, meaning that they could be tanks or cisterns or underground conduit or underground storage areas or something like that. They can be that, but they cannot have infiltration or evaporation or ponded area or any of those variables. Now the INP has to have that data, but it has to be left empty. Okay, so that's why when you see our project here, it only has name, inflows. Yeah, you can have inflows, but in this case we don't. So that could be a baseline inflow or a scale factor or something like that. They need an invert elevation and a maximum depth. And in our case, we don't have an initial depth, but in our case, we also give them a storage curve. Now we don't have a functional storage curve. I just have a tabular storage curve to give them kind of like a depth to volume relationship. And we'll see that when we get to how to build the storm drain system, but not here. Let's see, do we have anything about storage units? So if you want to learn about storage units, EPA Swim GUI give you some information, and then of course we do have somewhere in here, we do have a storage unit section in this model too. I'm not going to look for it, that's just going to take too much time. You can find it yourself. Oh, let's see. Let's get back to this guy. Okay, so we did outfalls. Let's do storage units. Yeah, so then a lot of these things I think are not required. Fields that are not used by Flow 2D have the 1, but they are required by the INP, but they are not used by Flow 2D. Okay, that's it for outfalls and storage units.